get him something like that. But okay, anyways, let's get started.
Oh,
So
okay.
that's neither here nor there. Um, anyways, okay, welcome, repeat customer here. Let's get right into it. Is Python your preferred language?
Yes.
Okay, cool. Okay, sweet. So today's problem, we're gonna be doing Leetcode, but it's gonna be a slightly different variation of the problem. So for this problem, I would like you to
Okay.
actually define a class. Okay, and in the
Okay.
class, we're gonna define the constructor, and we'll define a couple methods, right? And the goal
Okay.
is that you would implement the methods correctly, such that the if I, as the interviewer, were to call the methods, that I would get the expected result. Okay. So
Okay.
the class we're going to design today is going to be called kth largest, and how this class is going to,
Takes largest.
it's called kth largest.
Oh. Oops.
Yeah, kth largest.
Okay.
Yeah,
Got it.
kth largest. Okay, and we're going to support a couple methods. The first method is going to be it's going to be an init function, so it's going to be a constructor. You can choose what needs to happen inside of this method. The only thing that it has to take is integer k. Okay, is integer k.
Okay.
Okay. And then everything else you can choose how to implement. But the next method is going to be add. And add is going to take in a integer value. So you can call it val or whatever you prefer. So it takes in
Okay.
a value. And the goal is that you would add the value to your internal data structure to do whatever. And then
Okay.
you implement a function get. Get has no
Okay.
parameters, and it returns the kth largest element that has been seen so far.
Okay. And then is that it?
That's it. Well, for now. We can make it harder, but for now.
Oh, okay, okay. Okay, let me just reiterate this. So we're designing a class to support two functionalities, adding in values and getting the kth largest value seen so far.
Yep, that's right.
Okay.
Yep, yep, yep.
Will k ever be like greater than the size of our data structure?
I mean, k can be, but what we can assume here is that the user will add in enough values such that there will be at least k values inside the structure before they call get.
Okay. Okay. I mean, my initial thoughts would be to use a heap because we want to return the kth largest element. So I think a heap would allow us to efficiently access the
Mm-hmm.
kth largest element in our current structure.
Okay.
Okay. Um, Let me think though. So I guess like okay, let me think. Let me like actually simulate this. So if we're given like one, then we want to add that to our heap. And then if we're given like two, we store that in our heap. And then if we want to get, so then if we call get with the value one, then we would want to return two, right?
What do you mean by the value? Like with the value one?
Or I mean, like we call the get method
Okay. Yep.
with, wait, wait a minute. Oh, wait, get does not take in any parameters, right?
Yep. That's right.
Oh, so we always want to return the kth largest. Okay, so what if it's initialized with one, like k equals one? Then we'll always return the largest number. In this case, it'll be two, right?
We can do that. We could also say, I mean, you could define k to be that way. I would recommend us to say that k equals 0 means the largest,
Oh,
and
okay.
1 is the second largest.
Okay. So then in this case, we would return one.
Yeah, but you can
What
define
if
either way.
we add, do we want to support duplicate values? Like what if we added one and one?
Yeah, that's valid.
Okay, but would we still return one?
Well, is that the second
Yeah,
largest value?
yeah, yeah.
Is
Okay,
it
what
not?
if K was 2?
Okay, if K is 2, then you definitely return like 1, right?
Okay, but what if, wait, I'm trying to think of an edge case. What if K is like, you know what I mean? Like, um,
I know what you mean, but you have to vocalize it.
okay, what if there's like this situation?
Hmm.
Do we want to turn 1 or 0?
You can return either one, but you have to be consistent, right? So you're
Okay,
saying returning, like in this case, let's say your argument is returning 0, right? Then what you're actually saying
yeah.
is you return of the unique values the
Mhm.
third largest one, right?
Yeah.
If you want to say k equals 2 to return 1, then you say of all values you return the third largest one. So whether or not you use
Okay.
unique or not unique, you need to be consistent. But as long as you're consistent, either one can be okay.
Okay, so then it's up to me to choose. Okay. Um, I mean, also what we could do is just store these values in an array, and then each time we add a value, we can just sort the array, and then once we call get, we can just return like the kth element from the sorted array. Or in that case, we would have to sort it backwards. Like then the array would be like 2, 1, 1, 0. And then if k is equal to 2, then we can always return the element at index 2.
Okay.
But that's kind of inefficient because I would always sort the array.
Well, what would the efficiency be there? Like what's the complexity?
Like every time we sort the array, it would be n log n.
Mm-hmm.
So that would be the time complexity of the add method, and then the get method would be O of 1 since we're just accessing the kth index.
Okay. So if you don't want to do that,
Yeah.
what else is available?
We could use a heap.
Okay.
Um, Heap would be log n for operations. Um, and like for each call to add, it would be log n.
And what is n in this case?
And the size of the heap,
And what is the size of the heap?
k. I
Okay.
mean, um, I could construct the heap in a way to only have k elements, at most k elements at a
Mm-hmm.
time. It could be log k, actually.
Yep. That
Okay.
sounds pretty good.
That might be a good idea because then I'm limiting the size of the heap to k, which limits the time complexity to log k. So, okay, wait. In Python, heaps are min heaps by default, and since
Mm-hmm.
we want the largest element, then I think we should store the values, like we should make the values negative before pushing them to the heap so that, like in this case, the top of my heap would be -2, which is the largest value. And then, wait, let me think about this. Because we want the kth largest. So maybe it should be like, so, okay, wait. So if the size of my heap is limited to 3,
Mm-hmm.
because like if we're given k as 2, then that means the max size can be 3
Yep.
because it's 0 indexed. So if this is my heap, like let's say like the 1 is like the top of the heap because it's a min heap,
Okay.
then we would want to return the kth largest, which is 1, because that's the second largest or like third largest element here. So it just needs to be a min heap. We don't have to make the values negative because the kth largest will always be at the top.
Okay.
Does that make sense?
That makes sense on paper. Let's see how you implement it.
Okay. Okay, so I'm gonna call this class kth largest, and then I'm gonna define the initializer, and we're taking an integer k, and then I'm going to define my heap, and then is this incorrect?
The type goes after the variable name
Oh, okay.
with a colon.
Thank
Yeah.
you.
And you need a
Oh,
self. Yeah. There you go.
okay, and then I'm gonna store k as an element of the class. And then I'm gonna have my add method that takes in a value. Okay, and then I'm gonna add it to the heap. Oh, not heap. Heap queue. Heap. Okay, but I only want to push to the heap um if we still have room, if we haven't reached capacity.
Mm-hmm.
Actually, let me just initialize this as capacity and be like k plus 1 since it's 0 index. So I'm going to say if self, if the length of the heap is less than or equal, if it's less than self dot capacity. Actually, I'm always going to push to the heap, and then afterwards I'm going to check the length. I feel like that makes more sense. Okay, if it's equal to self dot capacity, if it's greater than self dot capacity, then I'm
You've
going to
gone
pop
through
from the
all
heap.
three possible comparisons.
Oh,
That's
sorry,
okay,
there's a
continue.
lot going on right now. Okay, so I'm basically always pushing to the heap, and then I'm checking if it's greater than capacity, then I'm gonna pop one element. Is there anything else I need to do? We don't want to return anything from this function, right?
Nope, yeah. Don't need to return.
Okay, and then I'm going to return the element at the top of the heap here. Okay, I think this makes sense to me. Should we run through an example?
Yeah, let's do an example. Yeah.
Okay. Okay, so let's say we add like a couple numbers like 1, 1, 2, 3, 4. So these are in my heap, and then let's say k is 4. K is 4, which means the capacity of my heap is 5. And then like each time I push to the heap, the minimum value will go to the top. And then if we call get, then it will return 1, which is what we expect. And then let's say I add 5 to the heap, then now it's greater than the capacity, so I'm going to pop the top element. So now these 5 elements are in my heap, and then if we call get, then it will still return 1. Okay.
Okay.
Let's say we add like a -1 to the heap, then this -1 will go to the top of the heap, and then I'm checking the capacity. Wait a minute. Okay. And then I'm checking if it's greater than capacity, then I'm popping it from the top. Oh, but then I'm popping the -1, I think. Um, that's not what we want, right?
Yeah, so there's going to be some logic we need to handle here for sizing up the heaps.
How would we know which element to remove, though? It should be the 5, I think. Because we want to remove, because this is now like, wait, would it be the 5 that we want to remove?
I mean, which one? Like, which else would you want to remove?
Hmm. I mean, I think it should be the 5 because that's the largest.
Mm-hmm.
Wait. No, it shouldn't be the 5. I feel like it should be the -1. Because we want to return the kth largest. So in this group of numbers, the kth largest is 1. So we should remove this, right?
Are you asking me for confirmation or just thinking about it?
I'm kind of asking.
Okay. No, I think that's right. Yeah.
Okay, then I think this is correct.
Okay.
We will return 1.
Yeah.
This makes sense to me. Does it make sense to you?
It does make sense to me, but you got me confused halfway. But it does make sense. But it does make sense now.
Sorry.
Okay, let's talk about the time and space, please.
Okay, so the time complexity for the add will be log n. Let me just write that. Log n. Because each of these operations keep push. Wait, sorry, log k. Because we're limiting the size to be k, k plus 1. And then each of these operations runs in log n time. And then this will run in O of 1 time.
Okay.
And then, space complexity will be O of k for the heap size. And then, yeah, that's pretty much it.
Okay. That sounds good to me. I want to ask a follow-up here, which is now we want to support a third operation. And that third operation is delete. Okay, so delete is going to take in a value integer as well. And if that integer doesn't exist, you do nothing. Like in your data structure, like you do nothing. If it does exist, you remove it from consideration.
Okay. What if there's multiple instances of that element? Like if we have 2 1s, do we want to remove both of the instances?
You remove one instance.
Oh, okay. Let me think. I think we can just traverse through the heap. I think we can just like iterate through the heap list and just check if the element exists inside. And then if it does, then we can just delete it by swapping it with the last element maybe. And then we can just call heapify. Because the element could be in the middle of the list, and kind of difficult to delete elements if they're not at the front or if they're not at the end. So we can just swap it with the end element and then heapify so that it's in sorted order again.
Okay.
delete, taking in a value from int. Do we want to return anything from this function or no?
No, it can just return nothing.
Okay. Okay, so I'm gonna loop through the entire list. If Okay, so if the current number is equal to the value we're looking for. Oh, actually, I should use the index. So for I, okay, then we want to swap with the last element. So I'm going to say self.heap at I is equal to self.heap at Wait, but one thing I'm not really sure about is I don't know how to delete, like I don't know how to resize a list. Like I don't know how to remove the last element of a list. Not gonna lie.
Like,
I
do you
could
mean?
just like, yes, go ahead.
Do you mean like? Do you mean like deleting it from memory, or do you mean like
Like if my
like
heap
deleting
or if
like
my
you have a
list
delete?
looks like this,
Okay. Yeah.
then like let's say I want to delete this index. Like I don't know
Mhm.
how to be like that.
Okay. You can use the del keyword
Oh. Oh, okay. Okay.
if you want to accomplish that, but I will ask you about that later.
Yes. Okay, so I'm basically swapping the current element with the element at the end of the heap. Yes.
Do you mean you're setting the
Wait a
current
minute.
element
Actually,
to the?
no, this is not correct because it's been heapified. So the last element, wait a minute. Let me think. Let me think about this very carefully. What if this element is the last element? And I'm like swapping it with itself, which is weird. Um, that might be incorrect. I don't think this is good. Thoughts?
You can get it to work. There's a like what you said at the very start is correct in that you can just like your goal is basically to remove the element one way or another. Like you don't really care how it happens.
Yep.
And what you said
Yep.
earlier does make sense. And what you said, I quote, is, well, I don't quote this because I'm not that confident, but I'm pretty sure what you said is you swap the element, like the ith element, with the
Mm-hmm.
last element, and then you
Mm-hmm.
heapify, right? That
Mm-hmm.
would
Yeah.
work. That wouldn't remove the element, but that would work. And then you can just remove the last element normally. So, for example, if you said, like what you said over here, you would have then you would
Uh-huh.
have self.heap. I mean, like what I said earlier is true. You could either do -1, you can do del like that, or if it's that element, you can just do self.heap pop, right? Just because it's a list, and then heap q.heap by, right? Like
Wait, does
that
this pop from the end of the list or the beginning?
should be the end, but you could.
Okay.
We can assume it's the end. It's fine. Yeah.
Oh, okay.
But this is what you said, right?
Okay. Oh, yes.
This is what you said, and
Yes.
this would work. What you didn't
Oh, okay.
um, what you didn't explain was why it would work. But if this is what you're stuck on, we can assume this works and move on from here. But if you would like to think about it some more, we could do that as well.
No, I think this works.
Okay.
This makes sense to me. I don't know why I was confused. My bad.
Okay.
Also, like, I don't really know if this is super efficient because, like, I have to loop through the entire heap to find the element if it's there. I
Mm-hmm.
mean, one way to check if it exists in this data structure would be to use a set or like a hash map or something
Okay.
to that like stores all of the numbers that we have in the heap. So if it doesn't exist, we wouldn't have to iterate through the entire heap to find that out.
Okay.
But then I have to create another data structure for that.
I mean, we can analyze the benefit there. So like, what's the time and space? Well, first of all, let's finish the problem, and then we can implement any
Okay.
optimizations. Okay. So how about we just continue the problem for now?
Okay. Yes. Um, is there more?
Yes. Right now, let's say you have this list. Okay. Thank you for the example. Okay, that list is too bad. Let me make a different one. Okay. Let's say I want to remove one, right? So del delete one. Okay. What happens?
Oh, because there's multiple instances, then I'm gonna delete it twice. But I don't want to do that, so I'm gonna, after I find the number, I'll just break out of this loop so we don't
Nice.
do it more than once.
Nice. Okay. Okay. One more thing I wanted to look at is the fact that you have this optimization. Okay. This made
Yeah.
sense previously because you can guarantee that if you add more elements to your structure, um, it would like there's no way to remove elements, so it will always be at least k elements in your structure once this condition is hit, right?
Hmm.
Now that is no longer the case. So let's consider this example. Let's do
Oh, okay.
k equals 2, and then we add in one. Let's just keep it super simple. Um, right. So I'm gonna add 1. I'm gonna add 2, right? And then so that's chilling.
Hmm.
That's all good. And now I'm gonna add 3. Okay. Uh,
Okay.
Now your capacity here is okay. Well, it's not there yet. So I add 3. So you're still okay. So now I add 4.
Hmm.
Okay. When I
Hmm.
add
Yeah.
4, this condition triggers,
Yep.
right? Because 4 is greater than 3.
Yes.
So
So then the one gets removed.
you pop off 1, right? So let's actually not pop it off.
Yep.
I'll just put in brackets here so we can see what's going on. What the hell am I doing? Okay, so
Okay.
we popped off 1. Okay. Now I add 5. Okay.
Okay.
Okay, yeah. So let's add 5. So I'm at 5. Now you pop off 2. Right. So 2 is also gone.
Yes.
Right.
Yes.
Now let's say I want to delete 2.
But two has already been popped.
But I don't care if it's in popped. I didn't tell you to pop it. Right. I'm the user of your data structure.
Oh.
Right.
Okay.
Deleting 2 is a valid operation because you should have it. Like in theory.
Oh, I see.
Like you see what I mean?
So you, so so when this happens, you're saying we still want to have the two stored in our data structure?
Yeah. Well, I'm not telling you how to do it, but you need to know that deleting 2 is a valid operation, and now you have to handle that case,
Okay.
right? Because I don't care that you have optimization under the hood, because now deleting numbers is a valid operation, and so you must handle it correctly, right? So let's just clarify. So now I can say delete 2, right? That's a valid operation,
Yeah.
and so you
Yeah.
should now do something else with this. I'll just delete it for here, right? And then now if I ask you, get, you should return 3. right?
Mm-hmm.
Okay, so that's an example that I want you to just think about.
But but how does this implementation not handle that? Because when we finish adding like up to 5,
Hmm.
the 2 is already gone from our heap. So when we delete it, nothing will happen. Like
Yep, nothing will happen in this
it will
case.
be gone anyways.
Yep, that's true. In
So
this case, it would work because deleting 2 is the same thing as not having it. But is that always going to be true?
yeah.
Like, for example, I made the numbers in order here just to make it easy to see. What if they're not in order? Will that affect it? Can you walk through that?
Oh, okay. So I guess like if we add them out of order, like 2, 5, or 1, maybe. So when we add 4 numbers, then it gets heapified, so it'll be sorted, and then we're going to end up popping the 1. So it'll be like that. Um, and then what if they say to delete? Wait, I can't think of the edge case. If they say to delete 2, I mean, that will work. If they say to delete
But
1,
wait, hold on,
it's
hold on.
already
Delete.
gone.
It's not to delete 2. It will work. Can you elaborate on that?
Wait, I meant like
Okay, so we
if
delete
we
2.
delete 2,
Okay, and then
then like this will get swapped, and then
and then
we remove
heapify.
it,
So it'll be what is then you
and then we
heapify that. So it'll be
heapify.
4, 5. Yeah. And then what will you return?
Well, we don't return anything in this function.
No, no, sorry. And then I say get.
Oh,
Right. Sorry. And then I say get. Now what do you return?
oh, okay. Um, Wait, but in this case, like, are we still assuming k equals 2?
Yeah, sure. We can assume k. I mean that's what you've
Oh,
done, right? Isn't that
yeah.
what you've done? Yeah. So we assume k equals 2. Yeah. Sorry.
But I thought we would only be calling get if we have at least 3 elements in this case.
But we do have 3 elements.
Oh, I see what you mean now. Because the user didn't delete the 2, we just deleted it.
The user
But
didn't
we still
delete
have.
the 2 or the 1 depending on your perspective. So we still have
Oh,
the
yeah.
elements. We have
Sorry.
1, right?
Oh,
We have 1
oh.
because you deleted 1 because you thought
Oh,
it was out of space, but I still have the 1 in my mind, right? I still know about it. So you should return 1 if I call
I
get in this
see.
state.
I see. Okay, then in that case, we can just if we don't limit the elements in the heap, then we won't delete any unless delete is explicitly called. And then for the get function, we can just hmm, that's kind of hard because I was thinking we could just index the kth element from the end, but I don't think that's how heaps work. Like you can't index the heap to get the kth largest element.
No, you can't.
So um, that is kind of tricky.
That is kind of tricky. What if we don't have this optimization? Would that fix things?
Like if we don't limit the size of the heap,
Mm-hmm. Yeah.
then we'll always have all the numbers.
Yes.
But how would I know, like, how would I be able to access the kth element? Kth largest. Oh, wait, I think there's like some built-in function called like n largest that takes in the heap, uh, self.heap, and then like the k value, and maybe
Yeah.
something else. I think that's it. And then this returns the nth largest.
Okay.
Can we use that?
I'll let you use that. Let's see how you use it.
Okay. think about this for a second.
This is. I'm letting you use the answer key.
There. Wait. Self dot. Wait. Let me change this then.
Okay. And do you know what this returns?
Yes. This. Wait a minute. Um, hold on. This might return a list of elements.
It does.
Actually.
It does.
Trying to think how these elements are returned. Like, definitely in some sorted order.
I can just tell you
Not
they're in.
entirely sure
I can
if
just tell you it's
it's
in decreasing order.
okay.
Hmm.
Okay, it's in decreasing order.
Yeah.
Okay. So then I think it would make sense to return the last element in this
Hmm.
list.
Okay.
Okay.
All right. Any other concerns about correctness?
Nope, this looks correct to me.
Okay. Does the delete still look correct? I'm not saying it's incorrect. I'm just asking you because you haven't considered that yet for this.
I'm just thinking. Yes,
Okay.
should still be correct.
Okay. Sounds good. Let's do the time and space, please.
Okay. Okay, so now that we're not limiting the size of the heap, then our operations will be log n, where n is the size of the heap, and space complexity will be O of n, because it can
Oh, then.
store at
Yep.
most, it can store like, it stores n elements.
Yep.
And then the get operation, uh, okay, actually, okay, I'm not really sure about this. Like in my mind, I think this should be O of 1 because it kind of seems like we're just accessing, like we're just slicing the heap, even though I know that's not how it works.
Hmm.
But like we're just
We can talk
getting.
about that. We can talk about that. We can assume
Okay,
this. Yeah. Yeah.
I'm
That's fine.
not sure.
Yeah. Let's skip it. Let's
I'm
skip it. That's
being.
fine.
Okay.
Yeah. I'm not torching on that.
Delete should be. Um, so for delete, we're looping through all of the elements in the heap, and there's at most n elements.
Hmm.
And then we are calling heapify. And this will run in log n time,
Hmm.
but this only runs once because after it happens, we break out of the loop. So the
Okay.
overall method is still bounded by O of n.
Okay. Cool. Uh. All right. Let's stop here and let's go through some feedback, shall we? But let me get some water
Okay.
first. I want to be. I'll be right back. I'll give me a minute.
Okay. Hello.
Okay, so let's go to some feedback, shall we? Usually for these, I like to
Yes.
ask, how do you feel, like in your shoes, how do you feel like it went? What were some things that you felt like went well or didn't go so well? So maybe let's start there, and then we can, of course, go through some of these solutions and feedback as well.
Mhm. Okay. Um, I thought it went okay.
Mm-hmm.
Like, I do think that my implementation was correct for the most part, but I feel like sometimes when I explain things, it's like a flow of consciousness, like it's just me speaking, and it could be confusing to the other person, but I can't really help
Mm.
that. That's just the way I think.
Yeah. Yeah.
So I feel like you were confused at some points, but it's just because I was saying what's on my mind. Because I don't like working in silence because then
Yes.
it
Yes.
makes you feel like you don't know what I'm thinking, and
Yep.
that's kind of
Yep. Yep.
awkward
Yep.
too.
Nope. That's
Yeah.
that's. I think that actually is kind of the
Um,
overall, like the high level stuff. I agree with. And sorry, I cut you off there. Go. Keep going.
oh, I was also going to say that I wasn't really sure about the time complexity of this function, and also I did not remember that it returns a list. So that's kind of a bad thing, I guess.
That's okay. Oh, that water didn't help. Okay, so let's go through some of this, shall we? Um, right off the bat, I think there were a couple good things I saw, and I want to say these up front because I think this is the more important thing, which is that the overall speed of implementation was pretty strong. The overall, like, I guess, intuition for the problem with the heaps is good, and the overall intuition with how we should handle, like before the follow up, how we should handle larger sizes with the optimization. I think that was quite strong as well. And I think overall, a good thing was that a lot of the first ideas you've said turned out to be correct. Maybe they're not fleshed out yet, but they turned out to be correct. And some of the later stuff you've done, like for example, with actually implementing it, you start doubting yourself, or you may confuse yourself a little bit, or you definitely confuse me, right? So, but I think your initial impression of the problem, your initial like your assessment, was quite good. So I think that's something which you
Okay.
should like keep in mind. Like it's
Okay.
like those multiple choice problems, right? Where like the first thing you guess is probably not going to be worse than after you think about it, right? So I think that's kind of the overall kind of theme is like believe in yourself. Your ideas are pretty good, and the interviewer, if they're asking some problems, they're not necessarily saying you're wrong. They're just like, I just don't know what you're talking about, man. Like I just need some help here. So that's a bit of a theme there.
Okay.
About the actual problem. So the initial problem you did solve optimally. That was basically exactly what we're looking for, right? Limiting the size of a heap, recognizing it's a mini heap,
Mhm.
all that's really like all that's fine, right? So there's nothing to comment on there, right? Now, obviously, the main meat of the problem is with the follow up in this case, right? And that would
Mhm.
be if it were allowed to allow deletes. Okay, the reason that follow up is really important and why it's the main problem is because it forces you to walk back some of the previous assumptions you've made, right? Like you cannot sorry, you cannot limit the size of the heap anymore. That's like basically the main limitation, right?
Yeah.
Um, and the intuition there that of course so you okay, so that's something you missed, right? Like you missed the fact that that's no longer a valid optimization. It's still optimization, just not it's still not correct. That's all, right? I think a big thing there comes down to you not having thought through a lot of the implications very thoroughly. And generally
Yeah.
speaking, that's because of two reasons. One reason is because you don't realize that it's a different problem, right? I don't think that's the case here, right? But of course, if it is, you can go back and study that. Usually, the reason is because you think, oh, yeah, I can delete problem. I can delete elements. That's no big deal. I may end up deleting elements anyways, right? But the big thing here, and this is why this sort of problem can be sometimes a bit confusing, like the one we design classes, is you have to think about the problem from the perspective of the user, right? Like things
Yeah.
that you can
True.
assume the user might not know, and things the user knows you might not know, right? So you
Yeah.
can't kind of cross that barrier willy nilly. You have to be conservative. You can't apply optimizations if you don't know about any sort of assumptions, right? Now you can ask about assumptions like, oh, can I assume that the user will always add even numbers or something like that, right? You can ask, but you can't just assume it, right? And so a big thing that really I think really does just comes down to this case, like walk through an example, like don't take it for granted the same examples apply, right? Think about it,
Hmm.
critically from the end user. Well, they know that I deleted number one. Like, will I ever need to return one to them again, right? So that's the sort of thing you should be thinking about. I think that comes with practice. I think that comes with a bit of like reflection. But I did want to just call that out. That would be like a demerit essentially in this case. Um,
Yeah, makes sense.
um, I want to spend a bit of time, of course, at the end, also talking about the time and space complexity. Before I talk about it,
Hmm.
was there anything that you specifically, now that it's no longer like a mock setting, like was there something that you thought is wrong and you think you might know what it is, but you want to just clarify it? Like for example, you mentioned in largest being constant time, right? O1. Can you explain to me why
Yeah,
you think
this
that's
is
the case?
definitely incorrect.
Okay.
Okay, I actually don't think it's O1.
Can you yeah, okay,
Um,
so this thing like this can obviously not be O1. Because if you could, you could just
yes.
call in largest on every element of array and sort things in linear time, right? So you can't do that. But can you just guess like intuitively, like, what do you think it could be? So it takes in two parameters. It takes in the k. It takes in a heap.
Mhm. Yes.
Also,
I
by the way,
think
I
it
will say
depends. Yeah.
before you answer, in largest does
Okay.
not require the heap to be a heap. It takes in any iterable, which I don't think you knew.
Oh, okay. I see. I think it would be um l- maybe like n log k. Like I think it depends on the value k that we pass in, or like n, I guess,
Mm-hmm.
and also the size of the iterable.
Yep, that's true, and that's also correct. It is in log k. Um, it is in log
Okay.
k actually because under the hood it just uses a heap. Like it puts so it's so this is a like a heap. It's and then it just puts all of the elements into a heap that's size k.
Mm,
So it's in log k
okay, and there's n elements in
because there's
the
n
size
elements. So it
k.
puts
Yeah,
n
that
elements
makes sense.
into a heap of size k, which is in log k. So that's how it works
Right.
in the hood, which is
Okay.
which is actually what you're doing here too, like previously what you were doing as well. So it's in log k. Um, I would say like if you could come up with that in an interview setting, that would be reasonable. I would say, like if you could come with it being unlucky, I think that'd be reasonable. Now, if they ask you why is it unlucky, that might be a bit more difficult. And truthfully speaking,
Hmm.
I don't see most interviewers letting you use the enlarges function. It's a bit too
Oh,
convenient
I see.
because for this problem, that's sort of the purpose of the issue of the thing, right?
Hmm. Yeah.
And it's also a bit of it also kind of defeats the problem because in largest doesn't require the heap to be a heap. It takes in any iterable. So this is actually
Mm,
useless
true.
per se. This is actually useless. So like that's just something to consider for the real world. Obviously, this is just a mock interview, so I won't grill you on that. It also, I think it'd also be prudent to kind of point out that um, in largest returns the in largest elements. You only care about the single in largest element, kth largest element, right?
Hmm. Yeah.
So, um, technically speaking, like in this case, people might ask you about like what are some other ways to do this, or why you think that this is optimal. I would generally speaking say that that's a bit more of a deeper question, but people might ask you, like that would spawn from a conversation about why are you doing anything here in the first place? Like, can we just use a simple list here and do the processing here
Mm,
anyways? Right. So that's
yeah.
that's a bit of something that you might want to think about as well, just in general about like why are you doing the enlarged over here? Because you could do it over here as well. You can just put it over here, right? So
Hmm.
I
Yeah.
would say that's a question you might want to clear up ahead of time. And I'll give you a tip here. This is a really good tip I think that people have found helpful. When you get these questions, I think it's really good to ask them, hey, what is the frequency at which the user will be calling each function? Okay. So for
Oh.
example, they might say, oh, for this structure, they'll be adding for every 10 adds, they'll do like one get, or for every one add, they'll get 10 gets, right? Something like that. Or,
Mm-hmm.
or, or they might not give you a quantity, but they might tell you, oh, add is called far more than get, or something like that, right? Why is that important?
Mm-hmm.
That's important because, yes, while your individual space and time complexity for these methods is correct, or time complexity rather, right? Um, that's not the full picture, right? Let's say, for example, that I tell you, oh, get will be called far more than add. Then what you should do is you should put this over here, right? Self dot blah equals this, and then return self dot blah, right? That's what you should do if what I said was true, right? Because
Mm-hmm.
yes, while the
Yeah.
overall space and time complexity, you analyzed correctly, you didn't consider the distribution of calls, and so if you didn't ask that and that was a problem that lent itself very well to an asymmetric call rate, then you would get penalized for that because you didn't think of asking that,
Oh.
right?
Oh.
So
Yeah,
that's
I
something.
did not even consider that.
Yeah, well, this is a big deal, right? Because let's say that get was called
Yeah.
like way more than this is 01, right? This is 01, this is whatever that is, right? So you gotta consider that. So it's a detail, right? It's a detail, but I would say it does matter. Okay.
Yeah, that makes sense. Yeah.
Okay. And then the last thing I'll say is this is actually like a double problem in the sense that like the follow up is not best solved necessarily with a heap. So like just how I said, when you get asked to follow up, you want to walk it back and say, okay, what assumptions did I make to reach my current solution? What needs to change? What can stay?
Mm-hmm.
And that's like an anchoring bias you have. Like you think, oh, because I've solved the previous problem with a heap, I want to keep using the heap. That's usually correct. However, sometimes it also helps recognize any patterns that come up. And by patterns, what I mean is, oh, if you were asked this problem from the start, how would you solve it? Like for example, if we're asking these sort of problems where a big part of the problem is dealing with these, sorted, like large sorted, you know, set of numbers, people will usually think of trees. People usually think of
Oh.
trees because, like, if I'm not talking about like the nth or kth of these keywords, I'm just talking about like large amounts of sorted numbers. People think of trees, right? And so when you realize, oh, actually, what I'm doing every time is I'm heapifying the entire thing, or if I'm deleting, I'm heapifying, or if I'm doing this, I'm heapifying. Then it should be like, oh, yellow flags, right? Like yellow flags. Why am I doing this every time? This might mean that heaps aren't the right structure. Because when you heapify, like I'm assuming you're aware, when you heapify, you're essentially building the entire heap, right?
Yeah.
Like, why am I
Yeah.
building the entire heap every time I delete an element? Like, is that reasonable? So that's something you might want to consider for the future as well. Like, just looking out for opportunities to kind of like redo or at least reconsider the underlying data structure, because it's not always the case that continuing to use the same structure for all the follow-ups will be optimal. And even if you recognize, like for example, this problem, oh, I recognize that using a complete binary search tree would be optimal. Um, you don't have to necessarily switch to it. You can say, oh, but I think it would take me a lot more time to implement that. Do you want me to switch over, or would you like me to continue with the heap solution? Right. So just even indicating that you are
Oh.
aware of that, that's points, right? And then depending on the interviews,
Oh. Okay.
depending on interviewers, let's say their schedule, their time, their intended follow ups after that, they might tell you, you know what, that's great, you mentioned that, but we'll just stay with this for now, right? But at least you acknowledge, hey, I know this isn't the best right now, but I want to just let you know that I'm aware of it. Okay, so just
Mm-hmm.
kind of keep that option available in the back of your mind as well, because that's oftentimes a testing point. Like, is this person flexible in thinking? Do they realize why they're doing something? So that's a call out for you
Mm-hmm.
to consider as well.
Yeah. Okay. Makes sense.
Okay. Any questions on your side? Otherwise, that's sort of the bulk of my feedback. I'll send you my notes after as well, but there wasn't anything too much here.
Do you think the speed at which I was solving it was fast enough,
I would say
or
we're
was
off
it
to.
slow?
I would say it's definitely not slow, but it wasn't fast. The first problem was done pretty well. The second one, I think if I didn't step in, you would have been pretty slow. Like, if I let you implement what you wanted to implement, and then let you know of the edge case you missed, I think that would be pretty slow. But
Right.
generally speaking, I don't think it's too big of a deal if you're able to do the base problems reasonably quickly, because the interviewer at least has a chance to help you, right? Obviously, if the
Mm-hmm.
interviewer's not in the mood to help, then nothing you can really do. But you can only control what you control, right? You can't control what the interviewer really does.
Mm-hmm. So was these like was the follow-up question your second question, or was there like an actual second question you were going to ask me?
This sort of depends. Like, for example, if you recognize that the follow up should be done with a tree, that would have been the second question, because that would require a redo of
Oh,
most
okay.
of the code. Um,
Yeah.
but if you had caught the edge case without me saying anything, then we would have had time for an actual second question. Yeah.
Oh, okay. Okay. Got it. Just was curious.
Yep. No problem.
Yeah, those were all my questions.
Okay. Cool. Thank you. I'll
Thank
catch
you.
you later. No problem. No problem. Happy
Okay,
to help.
cool.
Take care. Bye bye.
Yeah, you too. Bye.
All right. All right. All right. All right. We're gonna do resume reviews now. We're gonna do resume reviews. Get this loaded. Resume review starting at 13:05. Submit in comments. Link. Submit in link in comments. All right. Where is my link? Should be this, right? Yes. Why did I not copy? Copy. Boom. Pin. All right. I'll be back in a sec. All right. Let's see what we have today. What do we have today? Today is May 31. Okay. May 31. May 31. May 31, eh? Okay, time flies. Alright, this guy. I'm telling you, man, last week we had like 3 guys who checked the redacted box but did not redact jack shit. I'm telling you, man. Sometimes you feel like these people don't know how to read English. Alright, so your comment is looking for robotics embedded computer vision internships 2026 winter. That's coming up. What are your thoughts? Internship, last 2 bullet points, filter to see how much space I have. Any thoughts that make space roll into more bullet points? Current internship, we greatly appreciate it. Okay, cool, got you. Alright, let's take a look. Okay, Waterloo, DSA, RTOS, pretty nice, some stuff there. Okay, that makes sense. Okay, this is current, alright. Okay, GSI rated, kernel. 2 phase, okay. Okay. She's a bit low. That's fine. People don't know about that. Nice. Oscilloscope stuff. Do you have a favorite brand? I know some people are really particular about their oscilloscope brands. That should be lowercase. RTOS. Okay, that's fine. Internet software team member. Give me server controls. I see fun. Okay. Team of 10. Team of 10 is pretty impressive. I think even working in team of 10 is pretty good. So I think these 3 are honestly are decent. I think keep those on. Technology consultants. That's about all you need to put there. Blah 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 blah. Well, that's fine. Yup. 9%. That's good. I would say. Okay, hold on a second. Can you put this point higher up? I feel like this point is like better than other points. Because this point has some real data. You know what I mean? If you can put that one higher, I think it'd be better. Working with some stuff. Okay, blah blah. This is all right. Okay. Your question is putting in your question was no question. You're saying make 1 to 2 more bullet points for your current. Like, do you mean we have right now, or do you mean 1 or 2 even more than this? I would say the distribution right now is pretty decent. I don't think there's really much to change. Yeah, I don't think there's too much to change for the bullet points. At least from my perspective, most of the strength here is just with the past experiences. I don't think optimizations like we run the bullet points is really gonna help you much. So, personally, I think this resume is totally fine. I would encourage you to optimize other parts of your life instead. All right, moving on. Because you guys know, right? Diminishing returns. After all, diminishing returns. Very, very diminishing. So you gotta just be real with yourself. All right, let's see. All right, let's see. This person says, previously submitted with a focus of full-time new grad back in DevOps. I did implement the feedback I got from the video on top of the resume review channel on TC and Discord server. Now looking for final review. Okay. What is this? 2026 new grad. Okay, so like half a year. Okay. Okay, this is current. Okay, this is new. That's good. Yeah, if you're looking for stuff starting in the future, once this becomes a date, then you use the past tense like you have. If you're applying right now with it being the present, you would use present tense for the stuff you're currently working on. So like creating 5 API endpoints, etc. Right? Good data points. Good data points. I like that. Yep. Yeah, I think that's fine. I mean, look, you're in May right now. Presumably, it's for at least 3 more months, right? If you're gonna be on for at least 3 more months, then you gotta what are you gonna cut from this? Like what are you gonna cut from this? We're gonna add to this, etc. You're always thinking about that. Okay, contributed to. I mean, contributed to. I would say be more specific. I would say definitely be more specific on that. Uh, defended 20 user. That's a bit weaker. This is good. That's good. Maintained. Uh, Okay, that's good. That's good. Yeah, test automation intern. Yeah, all 4 points make sense. Own automation workflows, internal. Okay, streamline Jenkins file. Okay, blah blah blah. Python. Okay, this is fine. Okay. That's a lot of stuff. I like that. That's good. That's good. Good links. I like the links. Good stuff. I think this is exactly what you need to put. Like, especially if these are not very advanced projects, putting the experience reviewer makes a lot more sense. So this is perfectly fine. Quick scan, blah 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 blah. That's fine. Okay. So I think this resume is pretty polished up at this point. Couple things I would say. Again, the main focus here is your current experience. What are you gonna cut to? Because you got. I'm assuming you're gonna have more stuff, right? Like I'm assuming you're gonna have more stuff. You're only a month in out of your probably 3 to 4 months, maybe even 8. I don't know how long this is, right? But you got a lot more stuff to do, and you got not much room. So I would say, in my opinion, things that you should cut. Let me have a look. What should we cut here? Okay. I would say quantify this or cut it. Okay. Um, quantify this or cut it. This I would say is pretty good. You can cut this if you need. You can cut that if you need. You can cut that if you need. You can cut that if you need. What is this? This is a startup or something? $40,000 is nothing though. If this is a startup and this name is a startup name, then it's okay. Disregard what I said. Otherwise, I would cut that immediately. This is okay. 50% reduction is not that big, but I would cut that. So like these are the things I would cut if you need more room. Okay. Cut or elaborate. Cut or elaborate. Okay. Hey, the official name of my program is computing, but it's stated to be, but I'm assuming that says it is, but it is stated to be the same as computer science on the university website. Is that fine if I say computer science resume instead? Yes, it is fine. If you're from a school like SFU where they say it's a CMPT, in reality, no one fucking cares. Like, people are gonna be so anal that they'll renege your offer based on your transcript check. So I'd say yeah, it's totally fine to say computer science, but also these days that's actually a more and more common degree name, a more and more common major name. So I don't think that will actually cause you to get filtered out or anything. So I don't think you need to even lie. Any thoughts on AWS Certs like Solution Associate? I think they're completely worthless, and you should only go for those if you're no longer going for software roles. Like if you're trying to become a solution architect, right, which is what the cert you gave an example for is for, then yeah, I mean the certs are they're basically mandatory, right? If you're going for software roles, what matters a lot more than certs is actually using the products inside a project or inside your work, right? That's going to have a lot more weight than the certifications because everyone knows the certs are absolutely worthless. Okay, let's see who's next. Why is my sheet lagging? Okay. Oh, that's all. That's the two for today. Okay. Well, you know the drill. I will wait 5 minutes, and in 5 minutes with no more submissions, I will end it there. respond to you. Let's see. Nope, still not a thing. I want to put that as a thing. Submit resume form and comments. Why is we end at 1320? Damn, how does people find me? What the fuck? These guys find me from nowhere, bro. Alright. Alright, any other resumes? Oh, it's not 320. Okay, okay. I'll wait. Oh, there's one. Okay. Let's see. Alright. This person's comment. New grad backend. DevOps. Python. Okay, let's see. Okay. Are these links? If they're links, make them blue. Alright. Okay, 8. Okay. What? And asynchronous element output values to improve quality. Okay. I mean, async IO seems really weird. Why are we putting just Python library names in here? This is not relevant. I would not put that in a thing. You know, again, I would say using code coverage as a metric to talk about your test quality is not the right way to go. Developed document sharing system by designing pedantic models for DB schema. Developed document sharing system. So I think I don't know what the adjectives are here. So you developed a system by designing something? I feel like there's a disconnect there. Like designing and then you have to implement it, right? Yeah, I think your verbs are off there. Let's see. UTA. Oh, this is RA. Graph visualizer. Okay, sure. I would say the second point is probably not needed. This is just like this entire thing can be simplified by the word Docker Compose. Do you have Docker Compose over here? Yeah, so you're fine. Compile technology. Oh, that's a different format. Okay. Investigate fix limit for under 1 hour. That's not a point. That's not a point. You were here for were here for a year and a bit. This is pay, isn't it? Oh, this is pay, isn't it? Okay. Oh, I see. This is pay. Okay. Okay. Okay then. Okay. Person Linux. Okay. Wait, what? Oh, okay. I see. I see. Unit test again. I would say probably not the best use of space. Okay, so I mean, I would say I don't really like this is interesting. There's a couple things here which I would say don't really they don't really make sense. I know you spent like your pay here, but I would say there's some things which I would say are less leveraged. Like for example, this is unit test point, not that interesting. This is not quantified, that's not that interesting. See, this is quantified, that's cool. This feels like a bit of a you can just keep it on there. I know you're proud of it. Some of the other stuff I'd say, like think about it from the interviewer or the reviewer's perspective. Like, is this impressive? Like, does this demonstrate some skill that you don't demonstrate elsewhere? Right? That's sort of where you want to think about it. Does this bullet point here showcase a skill which I don't have showcased elsewhere? If it does, okay, does it necessitates me to put the second point here to really emphasize how good I am at this thing? Right? So I would encourage you to think about that from that perspective. This is fine. All right. All right. Okay. That is all the